Hello guys, this is CodeNCode and this is 11th lecture of this dynamic programming series part 1. So in this lecture we are going to see some kind of path queries on 2D grid. So there are different kind of path queries which ask you to minimize or maximize path on the given grid with a certain kind of movement. So there are two different kinds of path queries that we will be studying. The first one is, of course, this one. You are given a 2D grid of size n cross m, and you have to start from cell 11 and you have to reach cell nm. Each cell is having certain cost, so you have to find the path from cell 11 to cell nm such that which minimizes the cost of the path. Now the only operation you are allowed to, the only movement that we are allowed to make is either from a cell you can go down or you can go right. So these are the only movements that we are allowed to make. So we have to reach from here to here. You can take this path or this path, and the cell we are choosing starting from 11 to nm, all the cell that you are choosing to make a path, the cost of which we have to find a path which is minimum in cost, and we have to print. There may be some condition where the cost they can ask you to maximize. In this case we'll be looking for minimizing the path cost. The other kind of problem is again we are given a grid of size n cross m and we have to minimize the cost. We have to minimize or maximize the overall cost, and the thing that we have to do is we have to find a path that starts in any cell from the first row and ends in any cell in the last row. So we have to choose a cell that you have to find a path which minimizes or maximizes the cost, and the starting point must be in the first row and the ending cell must be in the last row. And the only operation we are allowed to make, only movements, there are 3. From each cell either you can go down or down right or down right or down left. So from a given cell you can choose another cell from the next row, either the cell which is directly below it or the cell which is like down right and down left. So these are the cells that you can pick. Of course, if you are on a certain cell where down left or down right doesn't exist, then you cannot make that movement. So starting from there are many ways to end. I can start from this cell and can take a path like this. The cost would be 6, 5, 11 and 4, 15. So we have to minimize or maximize the path. So all we have to print is either the minimum or the maximum cost according to the problem. So I'll be dividing this lecture in 2 parts. In first part we'll be only studying this problem, and in the next part we'll be dealing with this problem. So let's start. So to solve the first kind of problem where you have to start from cell 11 and you have to reach cell nm, and in this case we need to minimize the cost. The maximization is literally the same as minimization one, so that I'll be leaving you as an exercise. Now we have to minimize the cost of path from 11 to nm, and to do that we'll be using a DP array, a 2D DP array of the same size as the input. Now dp of ij would store the minimum cost to reach nm from cell ij. So suppose dp of this dp of 12 would store the minimum cost to reach dp of 12 would store the minimum cost to reach the last cell, that is nm cell, starting from 12 and reaching the last cell, that is nm cell, using the minimum cost path. So dp of ij would store the minimum cost to reach last cell from the i jth cell. Now to solve this problem, how we will approach, we will be filling this DP array, of course. Now suppose you need to go somewhere some of your destination, and the road the place you are currently at have two different streets, one on your left, one on your right, doesn't matter where it is. So both of them will lead you, of course, to your destination, but one costs 15 unit of money, whatever unit we are using, and the one on the right using one on the left costs 10 unit of money. On the right, the path on the right costs say 20, yeah, 20 units of money. Then which one you are going to choose? Of course the one on the left, because that if we are to minimize the cost, of course you want to minimize the cost, and the left the path on the left gives us, the street on the left gives us a path to your destination with only 10 unit of cost. So we will choose the one which gives us the minimum cost. Now here from this cell you can either go this street or this street, but the problem is we do not know, if I take this street, what is the cost that I'll be getting to reach your destination, because this all it tells, the one here is the cost of to reach this cell only. This is not the cost to reach your destination. Similarly, 9 is not the cost to reach your destination, but the only cost to step onto this cell. So we actually do not know whether taking this path would be beneficial or this path would be beneficial. We actually do not know, because we do not know what is the actual cost if I take this path from here to destination, or what is the actual cost if I take this street, the cost from here to here. We actually do not know. So to make our decision, we must know what is the cost to reach destination from this cell and what is the cost of destination from this cell. So before filling this DP of this cell, of course we need to fill these two so that we can make decision for this cell, right? Similarly for this cell, that is for this cell, what is the cost to reach destination from this cell? It depends on the cost of this and this cell, right? Because from here either I can take this cell or either I can take this cell. So this cell, to calculate its total cost or total cost, it depends upon the calculation of these two cells. It depends upon the cost, what cost would this give you and what cost would this give you if you choose this or this. So again, to make decision for this cell, we must know the cost of path from here to destination and cost of path from here to destination. Every single cell depends on some other cell. So we are not going to use recursive approach of DP, we are going to use iterative approach. In that case, when you are working with iterative approach, we start from that point where we start from base case directly. We start from base case. Now the base case, as we see here, each cell to calculate its cost depends upon some other cells, right? For example, this cell will depend upon this because there is no one on its right. This cell depends upon the cost of this or this to make the decision for it to choose whether this cell or this cell. All of the cells depend on some other cells to make their decision except the destination itself. If you are here, if you start your journey here, there is no way to go because this is the destination cell. So either you will go right or left, but neither the right cell is present here nor the below cell is present here, because this is actually your endpoint or your destination. So this cell doesn't depend on any other cell to calculate its cost. So this point we will call as base case. So we will start from here. So now if I take this cell, the cost to reach destination would be 8 itself. If I'm stepping on this cell, then the cost of reaching destination would be 8 itself. So DP of NM would be AR of NM itself, right? Now let's evaluate those which depend upon this. Now who will be the other which will be able to calculate their cost. Now you see this cell only depends upon the right because below there is nothing. Similarly, this cell depends upon only the cell which is below it because there is nothing on its right. So since we have already calculated the cost of this cell, so these two cells can make their decision. So now the only way to go for 4 from here is to go right, and the cost to reach destination if you step on this cell is actually 8, which we have already calculated. So if you start from this cell, the cost would be 8 plus 4, 12, and if you start from here, the only way you can go is down, and the cost to go down is 8 itself. So if you start from here, from 2 3 cell, the cost would be 5 plus 8, which is 13. Now since these two cells have calculated their cost completely, now this and these three cells can make their decision, because this cell depends upon the cost on these two cells which we have already calculated. This cell again depends upon the cost of this cell, which is 3 3, we have calculated it. Again this cell depends upon the cost of the cell which is directly below it, which is this 2 4, we have already calculated that. So now we can make decision for these three cells. So let's do that. Now this only depends upon the right, and the cost of right is 12, so this would be 12 plus 1, which is the cost of this cell itself. So the overall cost if you start from here would be 13. The overall cost if you start from here or here would be either you will take this path or you will take this path. Now this path cost 13, this path cost 12, so you would choose minimum of these two, which is 12, and this cell itself costs 7, so 12 plus 7 is 19. Now for this there is only one way to go, which is below, and this costs 13, so 13 plus 6, which is the cost of that cell itself, 13 plus 6 is 19. So we have calculated these three cells. Similarly we will calculate for these three, now for these two, and at last this cell. So you see, starting from first cell, the minimum cost to reach the last cell, that is nm cell, is 27, because dp of ij tells you the minimum cost to reach nm, which is the last cell. So dp of 11 will tell you the cost to reach nm from 11. So dp of 11, which is 27, tells you that the cost to reach nm from 11 is 27. The minimum cost is 27. So this would be our answer. Now if the question actually asks you to print the actual solution, you can print it really easy. So of course we'll start from cell 11, and then we'll move on to that cell which of course gives the minimum cost. So we see from 11 there is two paths, either you go right or you'd go down. So down gives you 25 cost, while going right gives you only 22 cost. So of course you would have chosen this. So your path consists of 11 and then this, which is 21 again, 22. Again from this cell you can move either to right or down. If you see the minimum of these two, this is minimum, so your path consists of this cell, not this cell. So this is one of the cells in your path. Now from here you see both of these cells contains 19 as cost, so you can choose either to go right or down, doesn't matter. The whole cost would be 27, no matter which cell you choose. So suppose we choose to go down, and then from here you see there are two ways to go, either this cell or this cell. So this gives minimum cost, so we would go down. So till now our path consists of these cells, and finally there is only one way to go, which is this. So this is the path that would give you minimum cost, which is 27. If you see in the original array, if you add all of the values on this path, you would see this is 27. The other path, if you choose this 19, is this and this. If you add all of the cost of the path from on this path, then the cost again is going to be 27. So you can actually print the solution from dp array. So let's see how we actually code this thing, because the problem is we can't start from here and then keep filling this first and then these cell and then these cell and then these cell. No, we are not going to do that. So what we would do, we would take we know that we said okay, we would start with a DP array of the same size as the input array, but we would start a DP array with one more row and one more cell. So if the row and cell are n and m, then we would take a DP array of size n plus 1, m plus 1. Now all of the values which are below and on the right, the what we say, the lowermost row and the rightmost column, we would fill with infinity except those cells which are directly right to the destination and directly below to the destination. Those two cells will fill with 0, the rest will fill with infinity. And this is table what we are going to fill with a sophisticated manner. So we will fill the DP array row by row, starting from right going towards left. Starting from the very last row, we'll fill first the last row and the second last row and then so on. This way we'll fill the row from nth row to the first row, and each row we will fill from right to left. So we would start from here and keep filling the elements till this point, and then we would go one row above and then fill all the values, all the cells from right to left, and so on. This way we would do this. Now we would start filling this element, which is the cost to reach destination if we start from this cell. Now the cost of this cell itself is 8, and there are two ways you can go, either right or down, but minimum of right and down is 0. So 8 plus 0 would be of course 8, and this is what we wanted. We wanted the DP of nm to be equal to AR of nm, where AR is your input array. Now we have filled this cell, we'll fill this cell. So the cost of this cell itself is 4, plus it can go either right or down. So minimum of right and down of course is 8, because the down is infinity and on the right hand side you are having 8. So minimum of infinity and 8 is 8 itself. So 4 plus 8 would be 12. You see why we filled infinity here. We filled infinity here so that we can for these cells we can ignore choosing the cell which is directly below them, because for these cell on the last row there is no way they can choose anything from below them. That is why we are filling them with infinity. Similarly, for all of the elements in the last column, there is no way they can choose a cell on their right. So that is why their right is filled with infinity. So there is no way they can choose that element. Again, now we will fill this element. Again, the minimum of right or below is 12, because below is filled with infinity. So this cell will choose 12, and the cost of this cell itself is 1. So 1 plus 12 is 13. Now for this cell, again, minimum of infinity and 13 is of course 13. So 13 plus 3 is 19. Sorry, 13 plus 3 is 16. So we have filled this row. Now we'll move on to n minus 1th row and fill it again, starting from mth column to the first column. We will start from here. You see, for this cell there is no way to go right. That is why we have filled with infinity. So the minimum of infinity and 8 is 8. So the cost would be 8 plus 5, which is cost of it itself, 13. Similarly, we will fill rest of the cell. There are many ways to handle this. You can't choose below or you can't choose right thing. So you can there are many ways you can implement this. This is one of the ways you can do it. So if I show you the code, I hope you have understood what was going on till now. So if I show you the code, this is the code. This is the input array, this is the DP array. We are reading n and m, which is number of rows and number of columns. Then we are reading input, nothing much. So now what we do, if you see, we fill n plus 1th row till m plus 1th column with infinity, right? So let's do that first. So run a loop from, just a second, so you guys have better view. In the last row from 1 to m minus 1, dp of n plus 1, this is the last row. I mean, we have n rows, but this is the n plus 1th row. which will be filled with infinity. So n plus 1th row, each column will be filled with infinity. Infinity is really long, really big number which you are sure that will not appear in the input. That is infinity. I have already defined infinity to something like 10 power 9, I guess. Yeah, 10 power 9. Now we have filled all of the cell in the last row as infinity. Now all of the column. So all of the column, how many columns are there? I guess for I is equals to 1, I less than equals to n plus 1, I plus plus, and dp of this row inside the m plus 1th column is equals to infinity, right? I guess this is correct. For each row we are filling row wise in the m plus 1th column, column row wise. Okay, till n plus 1. Okay, everything's fine. We have filled everything with infinity. Now these two cells, n plus 1 m and m plus 1 n, with 0. So dp of n plus 1 m is equals to dp of just a second, n plus 1 m and m plus 1 n, m plus 1 n with 0. Now this is pre-processing part done. Now you can start filling each row, starting from nth row, going to the first row, column by column, and we'll start filling from the mth column. J is greater than equals to 1, j minus minus minus. So we have mn for minimum cost. Initially initialize it with infinity. So either we go right or down. Okay, minimum minimum minimum. So each time minimum will exist, so there is no way to do this. So dp of ij is equals to cost of that cell itself. So ar of ij plus minimum of dp of I plus 1j or dp of I j plus 1. That's all. Now see what is happening here. So to fill each cell, of course we take the cost of that cell. That is why adding ar of ij plus minimum of either down or right. So this is down, I plus 1j, and this is right. So minimum of these two. So this way the dp array is filled. Now let's simply print the whole dp array. So I is equals to 1, I is equals to I plus plus, for in j is equals to 1, j less than equals to m, and j plus plus, see out dp of I j, and then print and else. So let's try to compile it and see that we get no error. So we have got no error. So let's try to run this. There are 3 rows, 4 columns, and the input is 5 1 2 6. Oh fish, just a second. I'll be running for the same so that I do not have to worry about confirmation, because confirmation is right here. So 3 rows, 4 columns, again 5 1 2 6 9 9 7 5 3 1 4 8. So this is the dp array, as you can see. Let me confirm it one more time. Yeah, so this should be the dp array, as we can see. 27 22 21 19, as you can see, the first row. 25 22 19 and 13, the second row, and 16 13 12 and 8, the third row. Answer is of course 1 1. So the cost to reach nm from 1 1 is 27. That is, you can print. So this was how you solve these kind of path query minimization or maximization problem. I hope you have got the idea how you would solve the maximization problem. That is literally too easy. So this was all for this lecture. If you have any idea or doubt, of course you can ask in the or suggest in the comments. So this was all for this lecture. Thank you guys for watching, and in the next lecture we will see the other type of query. So till the next video drops, keep coding. Thank you.